Hey everybody, this is Alex Merced, and if you've been enjoying this Intro to SQL series of videos, make sure to like and subscribe and leave a comment in the comments, and follow me on Twitter and LinkedIn. But today we're going to be talking about window functions. So all the code for today will be in this Windows functions.sql. This will be the last of the topics we'll cover from SQLite 3. Going forward, we're going to move over to using Dremio for our continuing exploration of SQL. So the next couple of videos, we'll set up Dremio and basically we're going to graduate to sort of the sort of to some other tools. Okay, but let's talk about window functions. So window functions, what they do is they allow you, they're different than aggregations, but can oftentimes fill similar use cases. So, and again, in an aggregation, when I did a sum, I didn't get every row back. I just got the result of the aggregation back. At best, I might got multiple rows if I did a group by, but I'm still not getting back the raw rows. What if I want maybe the results of those similar types of calculations, but I don't want to not get the raw row data? This is where window functions can kind of play. The first couple window functions we're going to use is more about kind of getting sort of a rank. So it's basically saying, hey, who has the best sales and who has the next best sales. So in this case, what we're doing is we have a table of salespeople or sales. So each sale has an ID, a salesperson, a region, an amount, and a sale date. We insert the data into the table, and now we're going to be doing this query right here. Okay, so essentially what we're doing is we're going to select a salesperson, a region, an amount, and here we're using a window function. So the window function row number gives a row number. So basically the first row is going to get 1, the second row is going to get 2, second row is going to get 3. Now I was like, wait a second, how's that useful? Well, the idea is that with window functions is that you have sort of certain groups that you would like to do this based on. So what would make sense here is that we would like to know, the row numbers for each region, okay? So, and then we're going to put those rows in order based on the highest sale to the lowest sale. So essentially those rows tell us who the best salesperson was, or the biggest sale for that region was, and the next biggest sale for the region, and the next biggest sale for the region. Makes it really easy to see sort of what the sales picture for each region is. Okay, so let's take a look at the result. So as you see, what we did here is we used this partition by statement that tells us, hey, how do we want to group this? So you're saying, hey, we want to group this by region. So you see all the east are together, all the north are together. Okay, so then once we have those groups, then it's a question like, how do you want to order them by? Well, we want to order them by the amount from descending, meaning the highest amount descending to the lowest amount. So once you actually have all the rows set up, it then does a row number. So now it's going to assign the first one for that group 1, then the second one 2, then 1, 2, 3, then 1, 2, 3. And that's essentially how row number works. Now, one thing to kind of point out here, if I take a look at, South, Alice did 600, but Bob and Charlie both did 500. So why should Charlie end up getting a rank of 3 when Bob had a sale just as large? Okay, that doesn't necessarily quite feel like it truly is a difference that should just get a number like that. So if you want to kind of capture that, that's where like the rank a window function can be really useful, because what this does is that if there's like similar values, so in this case if there's if they're sharing in the value that it's ordered by, they're going to share the same rank. Okay, so if we take a look at this, I'm going to stop running that, clear this out, hit run, and now take a look at the results. Okay, so actually let me resort this in descending. Stop. Okay, and now let's take a look at what happens with South. So see, Alice is number 1, but instead of Bob getting number 2 and Charlie getting 3, they are both ranked 2 because they both got the same amount. Okay, so they're not necessarily like, so basically it's truly a rank based on the value of the order by. So again, they're grouped by the partition by statement, but then the order by statement kind of determines sort of like the qualifier, like, okay, hey, this is what we're ranking you based on. So in this case, it's not just a row number based on the order that they're in, but an actual ranking based on the performance. Okay, so that's what we're doing here. So we take a look at there, you see again, Bob and Charlie are both going to be rank 2 instead of 2 and 3, like we saw with the row number window function. And again, why would I want to do this? Pretty self-evident, because I want to know who's getting the biggest sales in a particular region, so I can compare sort of the different salespeople in that region. Now let's take a look at another one, or another use of rank. Okay, and this one's going to be called dense rank. Okay. Generally, it's going to basically do the same thing with minor difference, so let's take a look at the result. Okay. So if we see here, and actually let's have both of them side by side, so you can really see the difference. Okay. Because they're otherwise doing the same thing, just a slightly different function. Okay, actually let me clear that out so it's easier to see the, there we go. Okay. So essentially what we see here is the result, okay, of the rank. So you can see here it says 1, 2, 1, 2, 3, 1, 2. Okay, and then here you get 1, 2, 1, 2, 3, 1, 2, 2. See, not too much of a difference. Okay, the idea here is if you ended up in a situation where you would have a gap in rank values, dense rank wouldn't have that, but in this case you really don't see that scenario. Okay, so again, this is probably not going to be particularly illustrative of the difference. For most cases you could probably use them both interchangeably, but again, the idea here is that dense rank isn't going to skip a rank value if for some reason in some situation you run into a situation where that might be the case. Okay, I am going to comment these both out now. So we're going to move off from this rank discussion. And now we're going to start using sum. Okay, so sum, the idea here is you want to add the amount. So you're going to say, hey, salesperson, region. And essentially what you're doing is you could sum for the region and then just get that region, you know, like each region's total. But I still want the information for each individual salesperson. So what this is going to do is create a column for each salesperson that's going to have the total for their region sales. So you're going to end up seeing the same value multiple times, but and again, you're going to see it as a running total. So let's actually see that in action. So I'm going to stop this, hit the trash can. Let's take a look at the results. Okay, so again, when we see here East, you see what it does, it sums up in order. So basically you say, hey, when Alice sold, and then when Bob sold for $350, our running total is 800. Okay, so the difference here between just a normal sum, instead of just getting that final number, you get to see the steps to that number. Okay, so you can see here 300. So of course the first number we see for the way we partitioned it, because again we partitioned it by region and we ordered it by sale date. So again, it's not by the amount of the sale, but by the date of the order. So that way, that the reason you would want to do that is because you want to see that running total in time sequence, not by number. Again, it doesn't matter to me what the running total is if you took the biggest sale first. What I care about is like, okay, how did the quarter go based on when these sales occurred? Like, how did we progress? Okay, did we have a strong ending? Did we have a strong beginning? And so forth. Okay, you know, in this case, I probably wouldn't mind having the date. So it's probably not a bad idea to actually add the sale date to the data that's in here. So if I put sale date as an additional field, we can make this a little bit more clear. So let me stop that, clear it out, run this again. Okay, and you can see that basically the date first, and I can kind of see, okay, hey, look, and with this, what I can do is I can see how the sales acclimate and grow, but also seeing it right next to it, I can kind of see, hey, like, you know, we really had a good like end of quarter or a real like strong beginning by taking a look at those dates and kind of see sort of that trail. And again, it's ordered by East, so I can see how like the story was for East. I can see how the different was for North and South, all sort of in one view. Okay, I'm not needing to do multiple queries to kind of dig at this story. Okay, so I'm like, oh, okay, got it. So if we went from 500 to 1100, 1600, I can see how that number built up. This could also be useful for auditing purposes if you're trying to kind of catch anomalies because a number doesn't add up to what you think it should be. You can actually kind of see that whole addition process kind of play out. And you can do this with pretty much any of the aggregation functions that we saw before. So I can do the same thing with average, and you can have sort of Basically, if we take a look at this one, basically we partition it. So we're doing an average. So we're not adding the values together, but we're partitioning it by region, ordering it by sale date. Okay. Rows between the unbounded preceding and current row. So let's actually just see how this plays out to kind of get an understanding for what's going on here. So let me clear that out. Cool. So bottom line, what we're seeing here is we see 450. Okay. And then we see 400. And again, it's just a running average. So basically average, that's why they call it average to date here. Okay. So bottom line is basically what this is saying is like the average between which rows. So basically the unbounded preceding, meaning the one that doesn't have another row before it. So basically the beginning of the list and the current row. So it's not doing all the rows, but just like in this case, like right now, Alice would also be the current row and the unbounded preceding. Okay, the row with nothing before it. So for east, that would be east. But for north, when we're doing Charlie, Alice would be the unbounded preceding because it's the row without a row before it. Okay, and then but Charlie would be the current row. So then all these rows would then be averaged, and then we get the 500 average. But when we get to Alice here in north, this first sale by Alice is the unbounded preceding, and then the current row is Alice. So then all three of these rows, because it's the rows between these two, all get averaged, and then that's how we get this number. Okay, so that's how when you read the syntax, that's what's happening here. Okay, it's always between like the first row and the current row, and then we include all the rows in between. Okay, so again, basically we're saying, hey, partition by region, order by sale date. Okay, and we get an average to date. Cool. But again, the benefit of this is, again, I'm seeing that across multiple sales. And again, I could put in the dates in there so I can see how the average sale changed throughout the quarter as the sales went in or throughout the period of time. Okay, and then we're going to have like lead and lag. Let's take a look at lead and lag. Now, the lead rank function provides access to a row at a given physical offset that follows the current row. Lag provides access to a row at a given physical offset. So you basically are saying, hey, give me the row that's like 2 before or 2 after, because maybe there's a relationship to them. Okay. So for example, here we're saying salesperson, region, amount, and we're going to lag 1. Okay. So basically what you're saying is like, give me the row before. Okay. Give me the previous row. Okay. So we're saying lag based on the amount column and give me the preceding row. But again, we're going to order it by sale date. So basically, I want to get what the previous sale was before this sale. In this case, we're not doing it by region. We're just taking a look at all our sales, and we're just trying to say, have each row be able to say, hey, this is the previous sale, and this is the next sale. So you can kind of take a look at that in one row worth of data. Okay, so if I stop this and I clear that out, okay, I can say, hey, Alice North. See, this is blank because there is no sale before that sale. And then the next sale is 500, which we see there. The previous sale was 300, which you see there, but the next sale is 450. And essentially that's what lead and lag do. They just allow you to like bring over data from the previous row. So I'm saying, hey, I want to bring over the amount of the previous row. Okay. And you might want to do that because you might want to grab some information about the previous sale, in this case, the amount, but you might want to have multiple of these because you may want the amount and the previous sort of agent to take a look at who's doing these sales and seeing like the timeline, like, oh man, like during this period of time, this person did a lot of sales, or kind of just plot that kind of stuff out. Okay. Also could be useful when you're building, having that information per row for when you're building like time series data or visualizations that can then make that, since they have that data set up in rows like that, you can create that visualization. So yeah, that's what a window function is. Again, it basically allows you to kind of create operations across multiple rows, but the result is you're adding a piece of information to the current row. So you're not going to end up with less number of rows. You're still going to have one record for each row. That's the result of your query, instead of getting like a summary, like an aggregation, which basically gave you just a single value at the end. Okay, these can be useful for different things. They are definitely something that takes a second to kind of really get comfortable with. So try these out and try them out on some other data sets. A great place to practice SQL after you've been watching this video series is to head over to sqlzoo.net. This is a great place where you can find little exercises to practice SQL in a nice, easy to use environment. Okay, so a great place to go practice. I will leave that there. So go try that out. But again, when we come back, we will set up Dremio and we'll be doing future SQL lessons from Dremio and talking more about Lakehouse and analytical systems and kind of going forward like that in the channel. So I'll see you guys there. Have a great day and enjoy.